Above the clouds, for centuries, astronomers fought against Earth's greatest enemy, its atmosphere. The same blanket of air that keeps us alive also distorts and blurs starlight. Even the best mountaintop observatories had to deal with twinkling stars, changing weather, and pollution. By the mid-20th century, scientists realized the solution was obvious but ambitious: put telescopes above the atmosphere entirely. At the same time, advances in electronics, computing, and engineering transformed telescopes on the ground. Adaptive optics sharpened blurry images. Arrays of dishes linked together to create super telescopes. And new detectors let us see not just visible light, but the universe in X-rays, infrared, and gamma rays. This was no longer about looking farther. It was about seeing differently, capturing the universe in all its hidden wavelengths. The Hubble Space Telescope, a cosmic icon. If one telescope symbolizes the modern era, it's the Hubble Space Telescope. Launched in 1990, Hubble orbits 547 kilometers above Earth, free from atmospheric distortion. Its 2.4-meter mirror isn't huge compared to some ground-based giants, but its location makes it priceless. The rocky start. At first, Hubble was a bit of a disaster. After billions spent, the first images it returned were blurry. Its primary mirror had been ground to the wrong shape by a fraction of the width of a human hair. The media had a field day, mocking NASA's space blunder. But in 1993, astronauts aboard the Space Shuttle installed corrective optics, basically glasses for Hubble. From then on, it delivered jaw-dropping images that changed astronomy and inspired the public. Hubble's legacy. Hubble showed us the age of the universe, 13.8 billion years, the expansion of galaxies, and breathtaking nebulae in exquisite detail. Its deep field images, capturing thousands of galaxies and a tiny patch of sky, revealed the overwhelming richness of the cosmos. It became more than a telescope. It became a cultural phenomenon: posters, coffee table books, even classroom decorations. For the first time, ordinary people saw the universe with a clarity once reserved for scientists. Chandra, Spitzer, and friends, the multi-wavelength theory. Hubble wasn't alone. In the late 20th century, NASA launched the Great Observatories program, a family of space telescopes, each tuned to a different part of the spectrum. Chandra X-ray Observatory, 1999, peers into violent, high-energy phenomena like black holes, supernova remnants, and hot galaxy clusters. Without it, much of the invisible universe would remain hidden. Spitzer Space Telescope, 2003 to 2020, explored the infrared universe, revealing dusty star-forming regions, exoplanet atmospheres, and even faint galaxies in the early cosmos. Compton Gamma Ray Observatory, 1991 to 2000, detected gamma ray bursts, brief, powerful explosions that are among the most energetic events in the universe. Together with Hubble, these observatories turned astronomy into a multi-wavelength science. No longer did we see the universe in just visible light, we now had cosmic vision across the entire spectrum. James Webb Space Telescope, the Time Machine. Launched in December 2021 after decades of planning, the James Webb Space Telescope JWST represents the pinnacle of telescope engineering. With a 6.5-meter segmented gold-coated mirror and advanced infrared detectors, JWST was designed to look farther back in time than any telescope before it. Because the universe is expanding, light from the earliest galaxies is stretched into the infrared. Hubble couldn't see it clearly, but JWST can. It's already captured galaxies forming just a few 100 million years after the Big Bang, rewriting textbooks in real time. Its sunshield, the size of a tennis court, protects its instruments from heat, allowing it to detect faint infrared signals. Its position at the L2 point, 1.5 million kilometers from Earth, makes it stable and efficient for long-term observations. JWST isn't just a telescope, it's a cosmic time machine, letting us witness the dawn of galaxies, the birth of stars, and even analyze the atmospheres of exoplanets for signs of life. Adaptive optics, fixing Earth's view. While space telescopes are amazing, ground-based astronomy didn't give up. Scientists developed adaptive optics, a technology that uses lasers and deformable mirrors to cancel out atmospheric distortion in real time. Here's how it works. A laser is beamed into the sky to create an artificial guide star. Computers measure how the atmosphere distorts that star's light and instantly adjust the telescope's mirror to compensate thousands of times per second. The result: images from Earth's surface that rival and sometimes surpass Hubble's clarity. Thanks to adaptive optics, observatories like Keck in Hawaii and the Very Large Telescope in Chile can see the cosmos with unprecedented sharpness. In fact, Keck was crucial in tracking stars orbiting the supermassive black hole at the center of the Milky Way, work that won a Nobel Prize in 2020. Interferometry, linking telescopes together. Another breakthrough is interferometry, where multiple telescopes work together as one giant instrument. By combining signals, astronomers can simulate a telescope the size of the distance between them. This technique reached global fame in 2019 when the Event Horizon Telescope combined radio observatories worldwide to capture the first-ever image of a black hole's shadow in galaxy M87. That image, orange, fuzzy, yet revolutionary, proved Einstein right once again. Interferometry is also used in arrays like ALMA Atacama Large Millimeter Submillimeter Array in Chile, which uses 66 antennas to probe the cold universe, star formation, protoplanetary disks, and distant galaxies. The future, giant telescopes and beyond. If you think we've peaked, think again. The next generation of telescopes is already under construction. Extremely Large Telescope ELT, a 39-meter mirror in Chile, expected to be the largest optical telescope ever built. 30-meter telescope TMT, planned for Hawaii, though controversial due to cultural and environmental concerns. Giant Magellan Telescope GMT, with 7 8.4-meter mirrors, it will rival the ELT in power. These giants will study exoplanets in detail, probe the first stars, and map dark matter and dark energy. And space telescopes. Plans are brewing for even more ambitious missions, like LOVOIR, a proposed 15-meter space telescope, and HABEX, designed to directly image Earth-like planets around other stars. A cosmic legacy. From Galileo's spyglass to JWST's GoldenEye, the telescope has been humanity's most powerful tool for exploring the universe. Each leap forward, whether in size, design, or wavelength, has expanded not just what we can see, but what we can imagine. We are no longer earthbound stargazers. We are cosmic explorers, peering back to the birth of galaxies, mapping the invisible universe, and perhaps one day, spotting signs of life light years away. The history of telescopes is far from over. In fact, the greatest discoveries may still be ahead. Eyes that changed the universe. From the moment Galileo lifted his humble spyglass to the skies, humanity has never looked at the night the same way again. That first trembling view of Jupiter's moons was more than a discovery, it was a declaration. It told us that Earth was not the unmoving center of creation, but just one world among countless others, dancing in the vastness of space. Since then, the telescope has grown alongside our ambition. Lippershey's lensmaker's curiosity, Kepler's refinements, Newton's mirror. These were not just technical upgrades, but philosophical shifts. Each design challenged the limits of perception, proving that reality is often far stranger and grander than what the naked eye can see. The giants of the 19th and 20th centuries, perched on mountaintops, gave us galaxies by the billions. Suddenly, the universe ballooned from a handful of stars to an endless sea of cosmic islands. It was a humbling revelation. Not only are we not the center, but we are barely a whisper in the cosmic choir. Then came the bold leap into space. Hubble, Chandra, Spitze, Webb machines not bound by weather, distortion, or atmosphere. They showed us the universe as it truly is, violent, beautiful, and incomprehensibly vast. Nebulae bloomed in color. Black holes cast shadows. Galaxies twinkled at the dawn of time itself. These telescopes did more than provide data. They gave us art, inspiration, and perspective. On Earth, adaptive optics and interferometry proved that innovation never sleeps. With lasers and supercomputers, ground-based telescopes sharpened their vision, linking across continents to glimpse what once seemed impossible. We now capture black holes on camera, trace the dance of stars around the Milky Way's heart, and peer into the cradles of planets being born. In the future, even larger mirrors, more sensitive instruments, and fleets of telescopes working in harmony. Perhaps soon we'll take the first true portrait of another Earth, blue oceans glinting around a distant sun. Perhaps we'll witness the universe's first stars flicker into life or catch whispers of civilizations far away. It is a symbol, a reminder that curiosity is humanity's defining trait, a lens through which we not only study the universe but reflect upon ourselves. Every breakthrough, every sharper image, every deeper gaze expands not just science but imagination. We began with a piece of glass in a wooden tube. We now wield golden mirrors the size of houses, suspended in the silence of space. And still, the same question echoes across the centuries. What else is out there? The telescope has taught us this much: answers are never final, horizons are never fixed, and the universe is always larger, older, and more mysterious than we dared believe. As long as we keep building better eyes, the cosmos will keep revealing its secrets. And maybe, just maybe, one day those secrets will tell us not just where we are in the universe. From Galileo's tiny spyglass to the James Webb's golden mirrors, telescopes have been our time machines, our storytellers, our eyes on the universe. Each new lens and mirror hasn't just shown us stars, it's shattered our assumptions, humbled our pride, and expanded our sense of what's possible. We discovered that Earth isn't the center, that our galaxy is just one of billions. That black holes are real, galaxies are ancient, and the cosmos is far stranger than our wildest imagination. And yet, this journey is only beginning. Future giants like the extremely large telescope and space missions still on the drawing board may one day capture the first real image of another Earth or glimpse the very first stars in creation. The telescope is more than glass and metal. It's a symbol of curiosity, a promise that as long as we keep looking, the universe will keep revealing. So next time you look up, remember those twinkling lights aren't just stars, they're invitations. The real question is, how far will we dare to go?